We're going to go over these problems 18 through 20. I know I went over 18 and 20 already. Those are the ones where you had to graph and label each triangle with the given vertices and determine whether each triangle is scalene, isosceles, or equilateral. Then you had to tell whether the triangle was a right triangle or not. And we can determine whether we have right angles in a coordinate plane by finding the slope of segments. Okay, and if their slopes are opposite reciprocals, then they're perpendicular and you have right angles. So on number 18 and 20, let me put those up here. I'll go over them again. Here's number 18. Number 18, they gave you three vertices of a triangle. All right, these were the three vertices they gave us, J, K, and L. They said graph them, so I graphed them. You don't actually have to graph them to find out what kind of triangle it is. All you got to do is find the lengths of all three sides given the points. Like for JK, we use J and K and the distance formula. When I plug that in the distance formula, remember it's x minus x squared plus y minus y squared. All right, when you plug it in there, I got the square root of 164 when I simplified it. Then I found KL, same thing, x minus x squared plus y minus y squared, and I got square root of 82. And then the third side would be JL, and I also got square root of 82 when I did those. So these two were equal. That means it's an isosceles triangle. You don't have to punch that in the calculator to try to simplify it or get a decimal form or anything like that. You can tell square root of 82 is equal square root of 82. So we're done. It's isosceles, right? Now that it's isosceles, they also told us to find out if it's a right angle. Well, just looking at the diagram, well, in either way, looking at the diagram, it looks like these two might possibly be right angles. So that's the two that we find the slope of. Or you can remember in an isosceles triangle, the only angle that could be the right angle is between those two congruent sides. Okay, because in an isosceles triangle, we have two congruent base angles. You can't have two right angles in a triangle. Okay, so we check the slope of these two, KL and JL. The slope of KL, y minus y over x minus x, and I got 9. The slope of JL, y minus y over x minus x, I got negative 1/9. And those two are opposite reciprocals. 9 and negative 1/9 are opposite reciprocals. Down here at the bottom, I write down that here's my explanation. It's a right isosceles triangle because JL and KL both have the measure of the square root of 82, so they're congruent and because their measures are equal. And then JL was perpendicular to KL because the slopes are opposite reciprocals. That's how we know that they're perpendicular, so that's what makes it a right isosceles triangle. Down at the bottom, what I did, just in case somebody was curious, the Pythagorean theorem, works with right triangles. The two legs of a right triangle, if you square them and add them together, will equal to the square of the hypotenuse. That's the Pythagorean theorem, a squared plus b squared equals c squared. So we haven't talked about it yet. It's in one of our later chapters that when we square, if this works, if a squared plus b squared equals c squared, then it had to be a right triangle. So all I did is I took the two sides that were congruent, squared those, and added them together, and they're equal to the longest side squared. And so that means it's a right triangle as well. Okay, that's another way of identifying it as a right triangle rather than just using slopes. All right, so I just put that on there. I didn't expect anybody to do it that way, but I was just go ahead and showing you that it would work that way. All right, then number 20, same kind of thing. We graph the triangle, find the measures of all three sides, HB, BF, and HF. And here they are. I got 2 square roots of 10 for HB, 2 square roots of 10 for BF, and HF with the square root of 80. Okay, so these two were congruent, so it's an isosceles triangle. Then I went back and looked at the picture and said, all right, it looks like these two might be right, form a right angle. So I found the slopes of BH and BF, or BF and BH. And I got 1/3 and negative 3. They are opposite reciprocals. So I wrote a similar statement to the last one. It's an isosceles right triangle because segment HB is congruent to segment BF. Both measures 2 square roots of 10. And segment HB is perpendicular to BF because the slopes are opposite reciprocals. Okay, so that's how we did it. All right, any questions? All right, number 22. These are the ones where we're trying to find out. They give us 4 points in a coordinate plane. They tell us graph and label each quadrilateral with a given vertices, then determine the most precise name for each quadrilateral. And when you're determining, it does not mean guessing. You show me why it is what it happens to be. So here's my graph over here. I got S, T, U, and V graph. Now, the best way to do these is with 6 slopes, because once you find the slopes of all 4 sides, you'll be able to determine if it's a parallelogram, if it's a rectangle, if it might be a trapezoid, or if it's none of those. If these are just absolute random slopes, then it's just going to be a quadrilateral. Okay, it could be a kite or could just be any quadrilateral. So first thing we do is find the slope of all 4 sides. Okay, so I found ST, TU, UV, and SV. Found them all. Here's the slopes. And notice there's 0, -2, 0, -2. So there appears to be a pattern. These two are equal. That means that they're parallel. These two are equal, which means they're parallel. They're slopes. So both pair of opposite sides are parallel. I even put the slopes on the picture so that you would see that. And of course, we could have looked at the picture and knew that these slopes were going to come out to be 0, right? Because they're horizontal lines. But I want you to find the slopes. Now, so I know it's a parallelogram. And now I can look at consecutive sides, like this one, and see if they're perpendicular. Are those opposite reciprocal slopes? No. 0 and -2 are not opposite reciprocals. You can't multiply those together and get -2. So it's not a rectangle. Right now, all we know it's a parallelogram. We know it's not a rectangle because consecutive sides, these two, they're not opposite reciprocals, so it can't be a rectangle. We don't have any right angles in this figure. Okay? So then it's a parallelogram. It's not a rectangle, so it's not a square, but we need to check to see if it's a rhombus. And the easiest way to determine rhombus, now I know you could find the measure of all 4 sides, and if they're congruent, it would be a rhombus, but that's a lot of work. The easiest thing to do, since we know it's a parallelogram, is just check the slopes of the diagonals. So the diagonals are VT and SU. The slope of VT came out to be -2/5. The slope of SU was 2/3. Those are not opposite reciprocals, so those diagonals aren't perpendicular either. See, that's what we're looking at diagonals, to see if they're opposite reciprocals, to see if diagonals are perpendicular. Since they're not perpendicular, it's not a rhombus. All it's going to be is just a parallelogram. So I usually write what it is. It's just a parallelogram, and then I tell why. Both pair of opposite sides are parallel with equal slopes. Consecutive sides are not perpendicular with opposite reciprocal slopes, so it's not a rectangle or a square. And then the diagonals are not perpendicular with opposite reciprocal slopes, so it's not a rhombus. So it's just a parallelogram, according to, my evidence, what I did. And this is undisputable evidence of what it is. And that's what you have to be able to give me. And then at the end, you summarize. Now, on some of these later problems, I give better explanations. Here, I write it down, but I'm not doing it the same way every time. So I started doing it the same way so you can get in the habit and you can see the easiest way to do it every time the same way. I say what it is, why it's a parallelogram, or why it's a parallelogram, why it's not a rectangle, why it's not a rhombus. Because if it's not a rectangle or rhombus, it's not a square. Okay? So you just say those 3 things you'll see in some of these other problems. All right, number 22. All right, that was 22. Number 24, same thing again. We graph the 4 points. Here's the graph. It's a big old square, looks like. But we have to make sure we find the slope of the sides. See, we do the same thing every time. Find the slope of the sides. From the slope of the sides, we can determine, is it a parallelogram? Yes. See, this segment and this segment have the same slope. This segment and this segment have the same slope. So opposite sides are parallel. Then we look at the consecutive sides. This segment and this segment, those are opposite reciprocals. 2/15 and -15/2 are opposite reciprocals. If you multiply them together, you get -1. So there are right angles. So it's a parallelogram with right angles. So it could be a rectangle, right? And it could possibly be a square. To find out if it is a square, it has to be a rhombus, right? So we get the slope of the diagonals. And this time when I found the slope of the diagonals, they're also opposite reciprocals. So that means this thing is a square. So I said it's a square. MNPQ is a square. And this is why I'm talking about I do 3 statements. It's a parallelogram because both pair of opposite sides are parallel with equal slopes. It's a rectangle because consecutive sides are perpendicular with opposite reciprocal slopes. And it's a rhombus because diagonals are perpendicular with opposite reciprocal slopes. If all 3 of these are true, then that means it's a square. Okay? So here's where I say what it actually is, and this is, just make these type of 3 statements. Why is it a parallel, or is it not a parallelogram? Is it or is it not a rectangle? Is it or is it not a rhombus? And the reasons are going to be the same every time. Okay? that make sense? All right, 26. Graph the 4 points. Find the slopes. The slope of the sides, there's 4 of those. Slope of the diagonals, I'm going to get 2. First, we look at the slope of the sides. Yep, it's a parallelogram. Opposite sides are parallel. See, these 2 slopes are the same. These 2 slopes are the same, so opposite sides are parallel. Is it a rectangle? No. Consecutive sides are not opposite reciprocals. If that's -1, that would have to be +1. If that's 1/3, that would have to be -3. And that's not the way it works. Those are not opposite reciprocals, so it's not a rectangle. Now, see, you know when you graph it, you have an idea. It's just that you've got to show me. Like I said, it's like doing a proof. Undisputable evidence. You've got to show me why it is what it is. So it's a parallelogram, but it's not a rectangle. So let's check and see if it could be a rhombus. Are the diagonals perpendicular? Well, here's the slope of the diagonals. One is -1/3, the other is 0. So nope, it's not. That's not a negative. Yeah, -1/3 and 0. So those aren't opposite reciprocals. So guess what? It's just a parallelogram again. Just a parallelogram. And I did my statements here. It's a parallelogram because both pair of opposite sides are parallel with equal slopes. It's not a rectangle or a rhombus. I put those in one step because consecutive sides nor diagonals are perpendicular with opposite reciprocal slopes. It probably would have been better if I'd have made all, separated rectangle and rhombus, so I'm doing it consistently the same every time. I still did the whole explanation, but, I guess showing you how to do it consistently will make it easier on you. You don't have to think about it. You can just know that you got to make 3 statements about why is it a parallelogram, why is it not a rectangle, why is it not a rhombus. Okay. Next one, number 28. 28, when we graph that one, it looks like a rectangle. And of course, we'll find out for sure. Find the slope of the sides. I have 1/2 and -2. 1/2 and -2. Opposite sides are parallel. They have same slopes. Consecutive sides are perpendicular because they're opposite reciprocals, 1/2 and -2. So this one is at least a rectangle. We find the slope of the diagonals. They're not opposite reciprocals, so it's not a rhombus, so therefore it's not a square. It's just going to be a rectangle. So I said it's a rectangle. It's a parallelogram because both pair of opposite sides are parallel with equal slopes. It's a rectangle because consecutive sides are perpendicular with opposite reciprocal slopes. And it's not a rhombus or a square because diagonals are not perpendicular with opposite reciprocal slopes. Okay, and that's my explanation. Any questions? All right, on number 30, when I graph this one and find the slopes of all 4 sides, you notice opposite ones, these two opposite ones are not parallel. These 2 are. I only have 1 pair of parallel sides, right? So what has 1 pair of parallel sides? A trapezoid. Okay, so we know this is a trapezoid because it only has 1 pair of parallel sides. That's what a quadrilateral with 1 pair of parallel sides is, a trapezoid. So if it's a trapezoid, we need to decide, is it isosceles? Okay, there's 2 ways you can find it's isosceles, but both of them are going to require you to use distance formula. You can take the non-parallel sides, these 2 that aren't parallel, and you can find their lengths, and that's what I did here, the length of the non-parallel sides. And if they're equal, then it's isosceles. I found the length of DE and the length of FG. They were both the square root of 32. So, yep, these 2 sides are congruent, so it's an isosceles trapezoid. Or I could have found the length of the diagonals. That's another way to tell, because in an isosceles trapezoid, the diagonals are congruent. So over here, excuse me, I found the length of the diagonals, DF and EG. Both of them came out to be the square root of 97, so they were equal. So either one of those would be enough evidence. Most likely people are going to be the length of the non-parallel sides, but you could find the length of the diagonals, do the same thing. So I said it's an isosceles trapezoid. It is a trapezoid because only 1 pair of opposite sides are parallel with equal slopes. And it is isosceles because non-parallel sides or diagonals are congruent. You could just say non-parallel sides are congruent. You wouldn't have to say diagonals also. I just did both to show you either one would work. Okay, you could just do one or the other. So here you would have had to use distance formula. Once you figure out something's isosceles, you will have to use distance formula. Now, there's one other case. We have parallelogram, rectangle, rhombus, square. We got to see different ones. And now we look at the trapezoid. And it might be that it's just a trapezoid and they're not It's not isosceles. The other type of quadrilateral we might have is none of these slopes are the same. Okay, if none of the slopes are the same, then it's just a quadrilateral, but it could be a kite, right? Because no parallel sides. So you would need to find the slope of the diagonals and see if they're perpendicular. If the slope of the diagonals are perpendicular, then that means it would be a kite. Because remember, kites have perpendicular diagonals. So the best thing to do is find 6 slopes, or start by finding 6 slopes. The slopes of the sides first. Then you'll know if you need to find the slope of the diagonals or if you need to find the measure of 2 sides that are congruent. So you've got to know these properties. If you know the properties, then you'll know how to use the formulas to find out what kind of figures they are. Okay? Shouldn't be too bad.